Okay, so this is our review before we take our quiz. Holy crap, why does this take so freaking long? Okay, so this is problem 15.9. And it says, suppose the cholesterol level of men 20 to 34 follows normal distribution with mean mu equal to 182 milligrams per deciliter and standard deviation sigma of 37 milligrams per deciliter. Choose an SRS of 100 men. What is sampling distribution of X bar? X bar. Let's just answer that question first, and then I'll answer the others. Okay, what they're asking for is, do you guys know what they're asking for? Who knows what they're asking for?
I think so. It's the distance of the...
They're asking for the mean, and they're asking for the standard deviation of X bar. Now, we did talk about that yesterday. What should the mean be?
Would be the population.
So
Same as the population mean, right?
And the standard distribution of a sample, right? That's what the X bar is.
Say it again.
They're asking for the mean and the standard
Deviation of X bar.
Sample.
No, of this sample.
So this is the
And Philip, I think you're on the right track.
Yeah, the mean is the population.
The mean should be the same as the population mean, which should be...
Those women has
100.
100?
those women has,
Oh, wait.
those women has a cluster of men and women.
We're only doing men.
Yeah, men age 20 to 34.
That's their ages. You know what my dad used to say? If this was a snake, it would have bit you. $182. Thank you, Jordan. It's right there in the problem. What should the standard deviation be?
37.
Nope.
Divided by the square root.
It should be 37 divided by the square root of the sample size, which is, well, the sample size is 100, right?
Sure.
The square root of 100 is 10. So 37 divided by 10 should be, you should be able to do that one in your head. 3.7. Okay? So it's asking you for the mean and the standard deviation. So the mean, because it's, remember, so yesterday we did this. Remember I said when we did those 900 students, and I says, do you think the mean of my means will be the same or different? Should be exactly the same, and it was exactly the same. So X bar should be exactly the same as the population mean, which was given right here. And then I said, is your standard deviation going to be the same or different? And it was different, right?
Yeah.
It was different, and all you do is you take whatever they gave you, in this case 37, and you divide it by the square root of your sample size. Okay? So when it's asking for the sampling distribution of X bar, the mean should be exactly the same. The standard deviation should be the standard deviation divided by the square root of that.
Which is the formula for standard deviation.
Which is the denominator. Yeah. Remember, yeah, it's the denominator.
The formula you gave us before, which is the standard deviation of the
Divided by the square root of sin, right?
But you don't subtract anything.
You don't have to subtract anything. All it's asking you is for what is the sampling distribution. The mean should be the same. The standard deviation you divide by the square root of n. That's all it's asking. Okay? Now, I'll call this A2. What is the probability that X bar takes values between 180 and 184? How do you figure that out?
Or you have to find the z-score based on the sample.
You have to find two z-scores, right?
Z-scores, and then you have to, just do the math to figure out the area.
Exactly, that's exactly correct. So we'll find the z-score for the 180,
Formula, right?
and we'll use the z-score for the 184. Say that again.
You're using the z-score formula.
Yeah, what's the
for
z-score
sample.
formula I should be using?
It's
So it's X bar.
X bar minus mu divided by
the standard deviation.
sigma. Don't say standard deviation, that's vague. Divided by sigma, square root of n. And I will underline that so it looks like a fraction. Okay. So in this case, what am I doing, Sandra?
subtract 180
180 minus 182 over
37
37 divided by
square root of
the root of 100. Okay. So now, whoops. I'm going to take this divided by that, which gives me a negative 0.54. What is that? It's my z-score. Okay. What do I do down here? Same thing. Jordan, take it away.
Want me to give you the numbers?
Yeah.
You get the 184 minus the 180.
182.
182. That's it. And divided by basically the same thing, which should be
Yeah, it's going to be that number again, right?
Yeah.
Okay. So that gives me this divided by that, which also gives me 0.5405. It's positive this time. Now what? Now I need to find my p-values, right? We're going to do this two ways because you need to know it two ways. We're going to do it with the chart and we're going to do it with the computer. Okay? Today's quiz is going to be which? Chart. Today's computer test is going to be with the computer.
Have
Okay?
you shown us how to do the p-value on Excel?
I did, but apparently it didn't record yesterday. I don't know why. That was weird. So we'll do it
I have
again.
no idea.
I did it yesterday, but apparently it didn't record. So, but I did do it yesterday. Okay? So how do we do it with the chart? Hopefully I can open up. Let's see here. Maybe I can open up. Oh, I hate this thing. I don't think this is the right thing. I don't want my UVU, I want my other one.
Want us just to pull up our-
Oh, here we go. Now I'll do it. I hope this doesn't take forever. This might take a while. So while this is syncing, we're going to do the computer first.
Well, you went to the PC instead of the OneDrive function in the files.
Okay, so how do we do this with the computer? Equals something?
Equal normal distribution.
Yeah, what's the norm S? Why do you think there's an S in there? Not because of sample.
Sigma.
Norm S dist. Why do you think the S is there? What does the S stand for? It's not sample.
Or standard.
Not for standard deviation. It does stand for standard. It's the standard normal distribution. So we're converting this, okay?
This is fine.
This is where the picture comes in helpful, right? Okay, what have we done with our thing here? I want to make sure you guys understand what's going on, because sometimes people get confused. Stop sharing.
Norm S disk.
Oh, I wasn't sharing. I was doing all this without the computer. Sorry, we'll show you that in a minute. But I thought I was sharing and I wasn't sharing. No, none of the computer work was recorded. It was just me. Okay, so what's going on with my picture? What kind of a distribution am I using?
It's a normal.
A normal distribution, right?
No.
What's the mean of my normal distribution?
182.
182. Okay. Now, I've got a sample of, so I've converted my 182 to a new scale. What have I converted it to?
On the normal distribution curve, and the standard distribution is 3.7. Right?
Yeah, but what have I converted this 182 to?
The one from the 82. No.
What's the mean of a standard normal distribution? 0, thank you. Okay, now I want to know the values from 180 to 184. I want this area in the middle, correct? Okay. So I've converted the 182 to a 0. What is the 180 now? Negative 0.54, okay, and positive 0.54. Now, because I've converted it to this scale, I can use either the chart or I can use the computer information, okay?
How did you get the?
All right. How did I get the negative 0.54? Okay, now I'm going to share my screen for the first time today. Although you all saw it, it wasn't recorded. Okay, so I did this math here, okay? So I did the x bar minus mu, so I did 180 minus 182 divided by sigma, which was 37 over the square root of 100. That gave me negative 0.54, okay? So I'm trying to find this area in the middle, okay? In the computer, I'm going to use the command equals norm s dist of that number right there.
And that's like using the chart.
That's not using the chart, but it's like using the chart. Yes, that's
It's not
correct.
using the chart, but it gives you the same information.
Gives you the same information as the chart gives. Okay, so what this is telling me, the area to the left, okay, and I'm going to use a different color, okay, is 0.29. Okay, now let me just explain what's going on here with the picture. Stop sharing. I wonder if I hit yesterday, I must have hit stop broadcast instead of stop sharing. Okay, so what I've done here is the area, I've actually found this red area. Or rather than the green area, I've found the red area. Okay, now what am I going to do? I'm going to do the same thing again.
The same value except for the 184.
Now, yeah, 184 this time. Okay, so when I share my screen here, okay, now I'm going to do norm s dist, okay, of that number, okay, and that's going to give me 0.7055. So going back to my picture again, what I've done is I've found this area here. Maybe I should use a different color. Oh, I got too much crap in my pocket. Can't get what I need. Okay, so I'm going to use this blue. So this area 2 in the blue area, including this tail, is 0.7055. Is that what I said?
Yeah.
Okay. So I've found the red area, I found the blue area, I want the green area. How do I find the green area?
That 1 minus.
Subtract what?
1 minus that.
Nope.
That's
I want the
exactly
green area.
Two of them.
If I take the blue area and I subtract the red area, I get the green area.
Yes, that's right.
So I'm just going to subtract those two values. Does that make sense? Blue minus red equals green. Because the blue and the red cover the same area, right? If I just subtract off the red tail, I get the green. Does that make sense? Okay. So, sharing it again. So the difference is the blue area minus the red area will give me the green area, which is 0.411. So the green area, I'm going to put my green, this area here, and green is 0.411. I'm going to go one more decimal. 411.2. We'll round it. Okay?
So if we were to find that other end of the tail,
If we wanted the white, then it would be 1 minus the blue. That's correct. Okay? That makes sense? All right, now let's see if this is synchronized enough that I can find what I'm looking for. Hopefully. Yeah, it looks like I've got it here, I hope. Okay. Now, if I were to do this with the table, here is the formula sheet that I'm going to pass out on today's quiz. Okay? So what do I do in this case? I'm going to go back to here. I'm going to use the same information I've used here. I'm looking for negative 0.54. Okay? So negative 0.54, so this is negative 0.5. I'm on this row. Go over to the column F, and I get 0.2946. Okay? Now this won't be as accurate as Excel, but it's going to be pretty darn close. So 0.2946. Okay, so the computer gave me more decimals. It's 0.2944, but this is what I would do if I'm doing it on the quiz. Okay? Now, how do I find this answer? The same thing, I'm looking for what value? 0.54. So if I look at positive 0.54, I'm at this row, this column, I'm looking at 0.7054. For comparison purposes, 7054. This one gave me 0.0055, so they're off a little bit, but they're close. We move this over here. Now, how do I find the difference? Equals that number there minus that number there. Okay? So the first time I got 0.4112, this time I get 0.4108. So we're off by 4/10,000ths, but that's pretty good, right? Close enough? You're off 4/10,000ths, I'll give it to you. Okay? So these are the two values that I got. One with the chart, one with the computer. Okay? Now, let me do one more.
I'm gonna raise it just yet. Let me raise it.
Oh, we're not actually done with this problem. Well, the next one is to do 1,000. So that's similar enough. All you're going to do is you're going to change that. Well, here, tell you what. Here's what we're going to do. Do it again when n equals 1,000. Okay, here's what I'm going to do. I'm going to copy all this stuff and paste it. Okay, but this time I'm going to change that square root to 1,000. And this time I'm just going to copy that. Okay, so the first time I got z-scores of 0.54 and positive 0.54, and now I got 1.7 and positive 1.7. Okay, so you can see that this is expanded bigger, right?
Yep.
Okay, now the chart, these values are wrong, but the computer are correct. So we went from 0.411 to 0.9126. It's a big difference, right? Went from 41% to 92%. Okay. Does that make sense?
Yeah, burgers, let's do this, please. I'm ready.
Okay, let me do one more problem because I want to make sure you guys know how to do this one.
What's the very last thing you said about the two, about why the differences are different? I guess I'll just listen to it.
Why are the differences different?
No, it's okay, I'll just listen
I was
to it.
actually just about to ask, large numbers, right? Our samples getting bigger, so we're getting closer to what?
Yeah, so what's happening when this, if this on the board illustrates n equals 100, okay? If this illustrates n equals 100, what happens when I do n equals 1,000? Does it get bigger or smaller?
It will get bigger.
It gets smaller, actually. It's going to have much smaller standard deviation. I kind of exaggerated that, right? Now, just for comparison purposes, it's probably not quite that skinny, but for comparison purposes, notice what happened to your standard deviation in the denominator, okay? We went from 3.7 to 1.17. So I cut it almost in a third, okay? Which made my z-scores go from a half a standard deviation to almost 2 standard deviations. Okay? So I drew that a little too skinny. It wasn't quite that skinny, but yeah, that's the idea of what's going on. Okay? So the black is the sampling distribution of when n equals 1,000. So you've got a much smaller standard deviation, but it's still centered at 182. Okay? So the bigger the n, the smaller your standard deviation. Yes.
Are we doing some kind of graph for that on the computer?
Well, it's too hard to draw. I'll give you, hopefully I gave you a piece of paper. I'll make sure you have scratch paper. I won't see your scratch paper, but if you want to draw this picture, it'll help you. It should help you. I don't know if it will help you.
You want us to draw that right now?
Only if you want to get the problem right. Some of you are just going to do it and not draw the picture, and you might get it right, and you might not. But the picture, it always helps me. That's why I say WWRD, and the answer is draw a picture. Okay? Now let me just do one more really quickly. Maybe I should assign you a few. We didn't really, we covered parts of chapter 14, but not enough. Maybe I should give you some good practice problems because there's a lot of problems that aren't good. But here's a good one.
numbers of I can color a lot more.
Well, these are just asking if they're binomials. Okay, here's a good one. I think this one
What
this one's problem 1436.
What page?
It's on page
Okay, go.
348.
348.
Okay, so John Carriage tossed a coin 10,000 times. He was a prisoner of war, so he had a lot of time. Apparently he had a coin too. He got 5,067 heads. Is there reason to believe his coin is not balanced? Okay. Now, how would we do this one from a statistical point of view? Okay. Something equals 10,000, right? What is that?
Sample size.
It's your sample size, and what letter do we use for sample size? N. He got 5,067 heads. What's 5,067?
H.
How about X? Okay. Is there reason to believe the coin is not balanced? Now, if it was balanced, how often should it come up heads? Half the time, or 0.5, right? So what would we use to say something equals 0.5? P, right? Why P? Because it's discrete, not continuous, correct? It's either heads or tails. So yes, no, true, false. Okay? All right, so if we're using P, what other letter should we be using? P hat. How would I figure out what P hat was? Okay, you're on the right track, I think. How often did he get heads?
Probability of success.
Probability of success in this case was 5,067 divided by 10,000, right? So he got 0.5067, okay? Which is closer to 51% than it is to 50%, correct?
I don't understand how you got P hat. Could you tell me one more time?
He got 5,067 heads, right?
Yeah.
Out of how many tosses?
10,000.
10,000. I just divided those two numbers. Okay?
So P hat equals the data point divided by the number of,
Yeah, P hat is X over N. It's the proportion of heads you got. Okay? Now, what's that other formula I told you about yesterday at the end of class?
P hat minus P.
P hat, slow down. P hat minus P over
Square root
PQ
over N. So
divided by
that's the
N.
Z-score for discrete data.
This is for discrete data, and this is discrete data, correct? Okay? So my P hat is what? 0.5067 minus my P, 0.5. And I'm going to divide that by the square root of, what's P? 0.5. What's Q?
So
1 minus P, which is 0.5 again. P and Q are the same in this case, because we think it's a fair coin. It's not always the same, but in this case it is. divided by 10,000, right? So I'm going to take my numerator divided by my denominator, and I'm going to get 1.34. Okay? Now, this is the time when I should, this is the z-score, correct.
I know. Then you should draw.
So what have I just done? I should draw a picture now so I know, so I can prove that I know what's going on. Extra credit for any pictures on today's quiz. How about that? Okay? So, how do I stop sharing? Oh, shoot, I was not sharing yet. I'll show you this.
This isn't on the video now? Is that what you're saying?
The video was recorded, my audio was recorded, but the spreadsheet was not recorded. Okay? But let's just do this. What's going on with the picture?
I'm paying like $900 to be here.
I know, and how many teachers record their videos? So you're lucky that I'm doing it. I think I'm the only one. So see the bonus you're getting for your $900? Okay, so what just happened with my picture? I think this is, at least on the board, right? Okay, cancel. So I've just drawn this picture. This is the coin problem, right? What should the mean be in this case?
Original mean or original?
Yes. The original mean should be 0.5. What did I just convert that value to?
0.
0. Okay. What value did I get? What did you say? I got 0.5067, right? I'm going to draw it here. What did I just convert that 0.5067 to? Z-score of 1.34. Okay, now my question to you is, okay, do I want to shade the area to the left or to the right? Okay, if it's to the left, it's going to say it's a fair coin. If it's to a right, it's going to say it's an unfair coin, right? Do I want to know if it's a fair coin or if it's an unfair coin?
We don't know if it's unfair.
We want to know if it's unfair, right? So am I shading the left side or the right side? I want the right side. I want to shade the right side. I want to know if the coin is unfair. Okay? How do I find this area?
You just,
Find the other part.
I've got two methods.
you got it in
Okay? Now I'm going to share my screen here so you can see all the work that I just told you about but didn't show you. It's now there. For $900, you got it. Okay? So now there's two methods. I can either do the table or I can do the computer. Which one would you like to do first?
Computer.
Computer, how do I find that?
the
Equals
norm.
norm s dist s dist, that one there. And then put in the z-score, which is 1.34, correct? Is that the answer, 0.90?
No.
No, it is
Subtract them.
1 minus that number. Okay? That's my p-value, 0.09. Now, is that unusual? No, it's not unusual because it's greater than 5%. Is the coin fair? Fair enough. Okay? But that was a little closer than you thought, wasn't it? You thought, oh, that's okay. But it's actually, if I said it was unusual at 10% instead of 5, would it be unusual?
Yes.
Yeah, it would be. Okay? All right, now how do I do this with the table? Okay, hopefully I can find my table here. Okay, what am I looking for on my table? 1.3, right? And then I go over to here and I'm going to get that number there, 0.9099. The table, 0.9099. Is that the right answer?
No.
No. 1 minus that. Okay, in fact, to 4 digits, those are identical, right?
Yep.
Okay. So it's not unusual because it's not less than 5%. So there's not evidence that it's not fair. Okay, you gonna ace my quiz?
I'm gonna forget my name,
Just
so
a quick
no.
question to bring the.
I brought your tables today. Yes.
Just a quick question. How do you get p hat again?
How do I do what?
P hat, how do you get it?
How did I get p hat? Bettina knows.
Data over n, like whatever.
Yeah.
So your data was the 50, 67 divided by.
P equals x over n and p hat equals x over n. They're the same thing. Which is your number of successes divided by your sample size. In either case. Okay? Does that make sense?
Sure.
Now you
My
can
mind
see
is
it.
like blank all of a sudden, man. I'm so screwed.
All right, so you ready for your quiz?
These would have been a lot better if I would have done it.
All right, hopefully you all turned in your homework for today, right? It was due at 10:30.
It was today?
Yeah.
Yeah.
Okay, tell you what, I'm gonna open it up right now. I'll make it 11 and then you can do it. So here, I'm gonna stop this.